Let's solve Leetcode question 33, search in the rotated and sorted array. So basically there's a nums array sorted in ascending order with distinctive value, and prior to being passed to your function, num is possibly rotated. So it's possible that everything in the nums array gets shifted and it's zero index. For example, 0, 1, 2 to 7 might be rotated at pivot index at 3, become 4, 5, 6, 7, 0, 1, 2. So part of it kind of like rotated, and you can see like 3 times, 1, 2, 3. So then that's why the array started at 4 and 4, 5, 6, 7, and then 0, 1, 2. So given the array nums after the possible rotation and integer target, return index of target if it's in nums, return -1 if it's not in nums. You must write an algorithm with O log n runtime complexity. So basically this is nums array here, and you can see this array is rotated and that the target is 0. It asks you to search for 0. And it's in the array, and the index is 0, 1, 2, 3, 4. So that's why you return 4 here, because you need to return the index. And here's another array. It's sorted. You can see 4, 5, 6, 7, and then 0, 1, 2, right? It's rotated, and target is 3, and it's not there. So I return -1, and then the nums array is 1. Target that I want to search for is 0. I couldn't find it, so it's -1. Here are some constraints here, and you can see this is like insane amount of company asked this question in the past 6 months. Definitely are great question to practice on. And just by looking at the requirement, you must write an algorithm with O log n runtime complexity. It reminds you that you have to use binary search, and especially that this is the array partially is sorted, and then essentially you can run this you can write a function and basically the same way as the binary search, and then the only difference is that you need to handle this situation a little different, because this sorted array is rotated a few times, but you don't know how many times it got rotated. And for binary search, remember that what we usually do with binary search is you started with a left pointer and a right pointer, right? For this, even though they're sorted array, but it's the same thing. There are two scenarios you have to think about. Let's say of course, if I put a mid value, it's not going to be midpoint. Midpoint is left plus right, like divided by 2, right? That's the midpoint of the array. Of course, the midpoint cannot be at 6 right now, but you have to imagine, let's say the midpoint is at 6 right now, and you can see that if the midpoint is 6, so left side of the array is sorted because it's 4, 5, 6, and left is small. When the left number is smaller than the mid number, that means the left side of the array is sorted. And then you can see the right side of the array is not sorted. It's partially sorted, like from the 0 to 1, 2, right? So if it's in this case, if the left side of the array is sorted, what you can do, that means that the middle number is bigger than the left side number. And if the target that they ask you to look for is bigger than the left side number and smaller than the right side of the number, that means the answer is in between here, right? So you want to move the right side to the -m-1 index to the left side array to continue to search in the left side array. But if it's not, then the opposite situation is that if it's bigger, then you're going to have to search in the right side of the array. Basically, L has to move to n+1, and then you continue the binary search on the right side of the array. So that's the situation when the midpoint is on the left side of the array is sorted. And let's say if the midpoint is not at 6, let's say the midpoint is at 0 and the right is at 2, right? So you can see in this scenario that the right side of the array is sorted actually 0, 1, 2. So what you need to look at if the right side of the array is sorted is that the mid number is smaller than the right side of the number. That means that the right side of the array is sorted. If the right side of the array is sorted, then I can check that if the target is within the right side of the array. If the target is within the right side of the array, of course I'm gonna look for it in the right side of the array, and I'm gonna move the left to the mid +1. In that case, if it's not bigger than the midpoint and not smaller than the right side of the number, then I'll have to, for example, it's bigger, then I have to search in the left side of the array. And then when I search the left side of the array, then I move right to m-1. So 1 point before that. That's how I do the binary search on the left side of the array. And if the midpoint is equal to the target, then I'm going to just return the index of the target that I'm looking for. So I'm going to show you how to do this in code. So I'm going to assign a left pointer and right pointer, and the right pointer is the length of nums -1, right, as always. And then for the binary search, I'm gonna say the while loop is left is smaller equal to right. So I'm gonna calculate the midpoint, which is same as before. Basically I'll left plus right in division 2, right? So I get the integer part. And then one easy case is if the nums midpoint is already equal to the target, then I'm just return the index mid m index, that's the target, and then I got the answer already. I can exit already, right? And the other scenario is that if the nums m is bigger than the nums l. Basically, let's look at it here. So basically that's the scenario that when we say midpoint is at 6, so the mid number is bigger equal than the left side nums, right? So when that happens, what are we gonna do? We're gonna check if the nums actually we're gonna check the target. If the target is bigger than nums left and the target is smaller than the bigger than or smaller than the nums mid. Basically, if the target is in between 4, 5, 6, right, we gonna move the right side to m-1. I'm gonna continue the binary search on the left side of the array because it's sorted, and else every single other situation I'm gonna just move the left pointer to the m+1 to I'm gonna search to in the right side of the array if it's not bigger. So then another situation for the rest of the situation means that the midpoint is here, let's say in the 0 situation here. That means that the nums m is smaller than the nums left side. Yep, smaller than the left side. And you can see in that case, what we're gonna check is if the target is smaller equal to nums the right side number and also bigger than the nums middle number, right? In that case, I'm gonna search in the right side of the array. When I search in the right side of the array, L is equal to mid+1. Else, otherwise, I'm going to search in the left side of the array, and then right will be equals to m minus 1. If I search the entire, go through the entire while loop, and I cannot find the target at all, I'm going to return minus 1 in this case. If you think this is helpful, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode question. Bye bye!